Welcome to Finding the Distance Between a Point and a Line, Part B. And again, I'm your host, Mr. Walker. And we left off the last video with the definition of the distance between a point and a line as being the perpendicular distance. In other words, the length of the segment between the point and the line that is perpendicular to the line. Thus, that would end up being the shortest distance between that point and that line. The question now is, how do we find that distance? Well, let's start by looking at a specific example. I'm going to place this on a graph and give you some information. So we've got a specific line now and its equation. Y equals 1/2 x minus 2. I've drawn in a dotted line which is perpendicular to the blue line and intersects the blue line at the point W. The point not on the line has coordinates that are given, 3, -5, and we don't know what the coordinates of W are, but if we did find them, we'd be able to use the distance formula to find that the length of that line segment or the distance between 3, -5 and the blue line. There are a number of tools, algebraic tools, that allow us to find the intersection of two lines. It can be done graphically or algebraically, but in order to do that, those tools rely on the fact that you know the equations of both lines, and we only have the equation of one line. So is there a way that we can come up with the equation for this dotted black line? And what do we need in order to find the equation for that dotted black line? We have the coordinates of one point, which are on that line, the point 3, -5, but we also know something about the slope of that black line. Since that's perpendicular to the blue line, hopefully you can delve back into your math mind to remember that there's a relationship between the slopes of two perpendicular lines. And that relationship is that the slopes of two perpendicular lines are opposite reciprocals. And then hopefully you've done this before and you've looked into this. If you haven't, that may be something you want to look up and brush up on. But if the slope of one of my lines, well, I can pull it right out of the slope-intercept form. That slope is 1/2. So the slope of any line that's perpendicular, and I'll use this little symbol for perpendicular, that is perpendicular to that line, should be the opposite reciprocal. And simplifying algebraically, this gives us -2 for a slope of that perpendicular line. And taking a quick look, just to double check, yes, that black dotted line does have a negative slope, and I could believe that it's steep enough to be a -2. So we now have the fact that the slope of our perpendicular line is a -2, and it passes through the point 3, -5. Can we use that information to come up with the equation for this line? Well, we certainly can, because we've got a point and a slope, and we have the point-slope form of a linear equation, which was developed in your algebra class. So using that form, all I have to do then is plug in. Well, notice that in this form, there is no x2, y2. There's only one point involved. There's one point and a slope, And that's exactly what we have up here. 1 point and a slope. So if we substitute, we would get y minus y1, which is a -5. Be careful of your signs. Our slope, which is a -2. And then x minus x1, which in this case is a 3. Now all we have to do is simplify, and let's go ahead and put it into slope-intercept form. So I'd start by removing some parentheses, and then subtract 5 from both sides. I get that as the equation for my dotted black line, or the line that's perpendicular to the blue line and passes through the point 3, -5. And doing a quick visual check, this equation tells me that line should pass through the y-axis at 1. Certainly looks like it. And has a slope of -2. And we already talked about that, sure, that looks like that could easily be a slope of -2. Now that we have equations for both lines, we can go on to do the necessary algebraic calculations to find the distance between the point 3, -5 and this point W, which we still need to find. That'll all take place in our final installment of distance between a point and a line, Part C.